Here is a new way of solving really difficult derivatives, and it's in your notes also. So please make sure that you double check the notes. This is just a second example of logarithmic differentiation. And let me tell you, if you're ever at a dinner party and you're trying to make people think that you're smart or wise or something, just throw out that word logarithmic differentiation. It will catch people's attention right away. But hey, here's the whole point. If I was trying to take the derivative of this right now, the way it is, I have a chain rule, and inside of that chain rule, I have a triple product rule, of which there's still a couple chain rules. So that is a chain pro-chain chain rule, which sounds very difficult. What we want to do is try and make it look a little easier. So if you ever get a problem that looks so ridiculously difficult that it just makes your eyes cross right away, try logarithmic differentiation and see if you can simplify it. Here's the first step. Take the natural log of both sides. Here's the second step. Once you've taken the natural log of both sides, see if you can rewrite this problem so that it might be a little easier. If this is all to the square root, that's being taken to the 1/2 power. By the power rule of logarithms, I can move the 1/2 out front. In fact, I'll go one step farther. Now with the product rule, I'm going to say, wow, this is 1/2 log of x squared plus 1/2 log of x plus 1 cubed plus 1/2 log times x plus 2. Now, feel free to make this a little bit easier. I'm going to move that 2 out front. I'm going to move this 3 out front. And I'll just keep that last one as is. I have now just rewritten the problem. I haven't used any calculus whatsoever yet. This is where I'm going to start using the calculus. But notice, instead of just a chain rule with lots of product rules mixed in, this is going to be 3 easy derivatives on the right-hand side, and actually one derivative that isn't too bad on the left. On the left-hand side, the one thing that most people will forget is that while that is the reciprocal of y, you have to multiply by the derivative of y, so please don't forget. The derivative on the left side is 1 over y dy dx. The rest of these, easy peasy lemon squeezy. And as a matter of fact, please do not try and find one common denominator for this. That is a bunch of algebraic hoo-ha. Actually, it works out nicely, but it's just a whole bunch of extra work. So now, the last step really is I'm going to take this derivative, and to really get it all by itself, I have to multiply both sides of this equation by y. So everything that was over here stays the same. I'm not trying to find a common denominator. I'm not trying to be a hero or do extra work. I just want to multiply both sides of this equation by y. So when I multiply both sides by y, what the heck is that? Well, don't forget, ladies and gentlemen, at the very beginning, y was equal to this long square root. To get rid of the y that was right here, I'll multiply both sides by y, and to rewrite it in terms of x, this is what y is equal to. Ladies and gentlemen, this is called logarithmic differentiation. I hope it just gets you so, okay, it's not exciting, but it makes an incredibly hard derivative much easier. Try it.